So you see the object now is almost 2 meters, 185, 87 centimeters. When it gets closer, you see that also the distance is smaller, while I'm keeping the same distance from the camera. Hi, welcome to this new video tutorial. My name is Sergio and I help companies, students and freelancers to easily and efficiently build visual recognition projects. We're going to see today how to check the distance of an object or multiple objects by using the Intel RealSense camera. Normally this is an operation that you can't do with just a simple webcam for one reason. The webcam doesn't provide depth information. So we need to use a camera which provides that depth information, which can be either a camera with depth infrared sensor like the Intel RealSense, or it can be a camera with LiDAR sensor. So there are multiple options that you can use. Today we will see the Intel RealSense camera. So what are the specs about this camera? It has an RGB camera so that you can see the frame, normal frame like we see this one, so normal video with colors. Plus, it has two stereo cameras which will get the depth of each specific pixel of the frame. And for this one also there is the infrared projector, which is this one at the center. So infrared projector, cameras, stereo cameras which get the depth, and RGB frame. This is the first thing that we need to check, the depth and the distance of the objects. Second, we need also object detection. Of course, if we want to check the distance of the objects, first of all, we also need to know where are the objects located on the screen. So now, before proceeding, I will quickly show you the installation and the files that you need to follow along with me, and then we will do everything from scratch, but it will be really simple and efficient, I can guarantee that. So let's start. Now, before proceeding, make sure that you have installed the library. So we need to install two libraries in order to follow along with this. One is the Intel RealSense camera, and the second one is Opencv. So to install the libraries, we can use the terminal. So on Windows, we type cmd on the search bar and we open the terminal. On Ubuntu or on the Mac, it's the similar process. You just look for the terminal and you open the terminal and use the same commands. Pip, if you have Ubuntu, you need to use pip 3, by the way. Pip install Opencv Python and you press enter to install Opencv. Then pip install PyRealSense 2 and you press enter to install the Intel RealSense camera. I'm not going to do that because I have everything installed already. And once you have this, it's not all. So we need still to get some files, which, by the way, these are the files. You can download the files from the link below in the description. All the files and more information and instructions to follow along with this will be provided on the link below. There is the RealSense camera file which we will import. So to get some simplified version of the RealSense camera that I wrote before, we have mask_RCNN, which is an instant segmentation algorithm which will provide the detection of the object, but also will have precise segmentation at the pixel level of the object, and you will see that. So if it's not clear what I am saying, we will see that later. It will make more sense. DNN, here are the files that we need to run mask_RCNN. So you download everything and it will be ready to run. I'm going to write part of this right now so that you can follow along. So make sure that all the files are exactly as they are with the same folder. So I'm going to import from RealSense camera. From RealSense camera, we're going to import everything like this, asterisk. And let's now run the RealSense camera. So first of all, we load RealSense camera. We say rs equals RealSense camera. So before you ask, this is not a library. This is the file that I've created and you need to download. So if you import this one and you get an error, it's because you didn't download the files and you didn't put the files on the same folder. RealSense camera. So if everything is correct, we run this one and we see loading into RealSense camera. Of course, we don't see anything because we're not doing anything with this. Let's now get the frame from the RealSense camera. rs.getFrameStream. So from the RealSense camera, we're going to get three things: ret, BGR frame, and depth frame. Ret is just simply saying if there is a frame is true, if there is no frame is false. So let's say, let's show the frame cv2.bgr. Oh, no, sorry. First of all, let's import cv2. Import cv2, and then cv2.imShow. What do we want to show? We want to show BGR frame. So to make sure that the Intel RealSense is getting correctly the frame, BGR frame, and then BGR frame. Now cv2.wait key to keep the image on hold so that we can see it. Wait key event. So let's run this one. If we see a window with the frame, then something is working fine. And it's working fine. So we have that. Doesn't matter now the lighting, that will be fixed later. And we've got now BGR frame. So we're getting the frame, but we got only one frame. As we want to work with this in real time, let's get the frame after another. What is the difference between a picture and a video? Well, it's the same thing, but with the difference that the video is a lot of picture one after the other. So we have 30 pictures, 30 frames in 1 second. While true, so we put everything on a loop and we keep getting frames non-stop. So while true, we get the frame, we show the frame cv2.imShow. I deleted it. Let's rewrite this again. BGR frame, and then BGR frame, and then a wait key event key equals cv2.wait key 1. So it waits 1 milliseconds if we press the key. So if key is 27, which is the S key on the keyboard, we want to quit. So if we press the key, it will quit the loop. If we don't press anything, it will start again, go to the next frame and show the next frame. And let's try this one and let's see if we're getting the frames in real time. And this is from the Intel RealSense camera. So we're getting the Intel RealSense camera frame, but this is just the BGR frame. We don't have any depth information in this one. Let's also see what do we get on the second frame, on the depth frame. The depth frame, this one, if we show, let's print depth frame and let's run this one. As you can see, the depth frame right here is providing some numbers. The depth frame has the same size of the original frame, with the only difference that instead of being the pixel which show the frame with the color, it shows the distance. So to give you an idea, I'm going also to show cv2.imShow depth frame, depth frame. So you see we have the depth frame and BGR frame. They have the same size right here. Of course, normally you don't display the depth frame. This is not the way to use it. I'm doing this just for you to understand what is this array with depth frame. Each value right here is the distance in millimeters. So for example, if we take the first number, it means that the first pixel on the top left point is distance from the camera 2700 millimeters. The second pixel has the distance of 2700 703 millimeters, and so on. So just to give you an idea, let's try to get some depth information of some random pixel on this video. So if we want to get the depth information, that's actually really simple, just to get the depth from the frame. And we can do that this way. Distance in millimeters, so let's say distance mm, equals depth frame. From this depth frame, we need to provide the position in pixels on the frame. The position we need to provide first on the y-axis and then on the x-axis. Let's say that we want to get the position of the pixel 100 on the y and 250 on the x-axis. And let's print this value. Print distance mm. So the pixel we position, I forgot which was the position, 150 is around 3700 millimeters. How do we know which exactly pixel is here on the frame? Well, of course, we can also put a circle on some elements that will help us understand on what position we are focusing. So in this case, we have the x, so let's say point x and point y equals 250 and 100. So we will use this. It will be easier to change the information later. Also, let's draw a point on this. Let's draw a circle on this specific point. CV2.circle. Where do we want to draw a circle? Let's draw the circle on the BGR frame. So we draw a circle on BGR frame. Now we need to define the position of the circle. Of course, we're going to say the same position because we want to know the circle where we get the distance. So we have point x and point y. Then now we decide the size of the circle. It doesn't really matter. It's just for us to see the circle. So let's put a big circle so that we can see it well. Let's say 8 of radius. Then the color. Let's make this one red so that we can see it well. It's 255 and -1 so that we fill the circle with the color. And now let's run this one. So exactly we're getting this position right here. So you see that red dot. Oh, okay, I forgot to print the information anyway. So we can also show the distance in real time this way. CV2.put text. Where do we want to put the text? We put text on BGR frame. Then what do we want to show? Let's show the distance in millimeters. So we say this dot format. So we're putting the string BGR distance millimeters. Okay. Now, where do we want to put the text? It doesn't really matter. Let's put it together with the circle, just a bit upper so that it doesn't overlap the circle. And then font. I'm going fast right now because you don't really need to know all this right now. So I'm just displaying a text to show in real time the distance of the specific point on the screen. So I'm drawing the text on the screen. So this is the font type 0. So if you change the number, you change how the font will look like. Then font size, let's say 1, and then the color. Let's make also this one red. 0 of blue, 0 of green, and 255 of red, and then to the thickness of the text so that we can see it well. And let's run this one right now. And right here you can see the distance of the wall of the ceiling really well, I can say. Why is not so precise? Well, this camera is accurate from around 0.3 from 3 centimeters to up to 3 meters. So in this case, the ceiling is farther than 3 meters. So of course, it's not so precise. So this camera is not made for big distances, by the way. 3 centimeters to 3 meters. Now that you know how to get the information of a specific pixel, a specific point, what if we want to get the information from an object? Let's say that I want to get the distance of myself from the camera. We will now implement object detection. In this case, I'm going to do something more advanced. I will use object segmentation so that we will have also the mask of the person. So let's do that. And this is really simple because we will just import from mask RCNN, import everything. Keep in mind, this is not a library, this is a file that I've created that must be on the same folder of your main file. So if this gives you an error, make sure that you have the file on the same folder. Mask RCNN, and then let's load mask RCNN. IMRCNN equals mask RCNN. I'm going to hide something from, I'm going to delete these things that we don't need. So everything regarding the distance, it was just for you to understand how it works, but we don't need that because that will be done by the library. So here we get the frame. So let me add some comment, get frame in real time from RealSense camera. Once we get the frame, we want to detect the objects. How do we do that? We have mrcnn dot detect objects mask. Where do we want to detect the objects? We want to detect the objects from the BGR frame. So once we detect the object, we're going to get in exchange some information. And in this specific case, mask RCNN is going to give us 4 different arrays. The first one is the boxes. The second one is, actually, I wrote this before, but I don't remember in which order we get them. So let me check. We have classes, contour, and centers. Boxes, classes. So boxes, the rectangle of where the object is located. Classes, what is that object? Is a person, is a pen, is a pencil, is whatever it is. Classes. I forgot again. Okay, contours, and centers. Contours is because we do not only get the rectangle surrounding the object, but also we get, if it's a person, we get the precise boundaries of the person. So we get the mask, which are provided by contours. And finally, also, we're going to get the center point. So this is the point that we will use to get the distance. So on this point, we'll get the information from the depth camera. So centers, and how do we go further now? Let me show you what we get from here. Let's print boxes. Let's print classes. Print contour, and then print centers. Print, okay, I'm going to, just to make a distinction between them, boxes. Again, you don't need to do that, but I want that you see what we're doing, because if you go with this without understanding what is on each step, then if you want to make even a small edit, you will be lost and not know what to do. If you work from the basics your way up, then it will be much easier. Contours, and then centers, and let's run this one. Okay, it should be fine. So I'm going to run this one, and let's see what we get from this. By the way, it takes a while to load mask RCNN. And of course, it will make things slower, but we will see that step by step. So let's go up and let's see what we have here. So we have boxes. 300, this is the box. In this case, probably we have only one box. It means probably that only the person was detected. Boxes, 360, these are the coordinates of the box. Classes, to the class corresponds the object. So in this case, is associated with a text file. Class 0, what is class 0? Class 0 on the list, so is the first element is the person. So it means that a person was detected. What else do we have? Okay. Contour, here are the boundaries, exact boundary of the person, in this case it's me. And then we have the center, this is the center point of the person. If I had to display everything now step by step, it will take a long time, so I decided to also simplify this one with the mask RCNN file that you will download from the link below. And so to draw the mask, we can use one simple command, imrcnn dot draw object mask. Where do we want to draw the object? We want to draw the mask on BGR frame. So BGR frame equals imrcnn. Let me add some comment. Get detect objects or get object mask. Draw object mask. And let's now run this one. By the way, keep in mind that I'm using the graphic card NVIDIA, and in order to use that, it must be compiled. Let's say it's a complex installation if you are not familiar with this. So that's why it has a specific speed of a few frames per second. If you're just using your normal computer processor, it might get 1 frame per second or even less. So if it's going really slow, it's not a problem of your computer, it's normal. It's supposed to go slow if you don't do an advanced installation with the graphic card. So this is, by the way, the mask. Let me also get some other object. So, okay, this is a chair. So you see that each object has a specific mask. So if I get the bottle, it has also a different color. So it works really nicely, this one. Now it's one of the most important steps to get the distance of the object. So in this case, we will take, for example, the center point of the person and get like the position of that one. To make this simple, we can do and show everything on the screen. We can load another function or show depth info of the objects. How do we do that? mrcnn dot, and somewhere here we have the function, okay, draw object info. And we need to provide where do we want to draw the object info on the BGR frame. And also we need to provide the depth frame so that it can get the distance of each specific object. Depth frame. And let's try this one. Okay, let's see, it takes a few seconds to run. Okay. Now, have a look. We have person and we have the centimeters written on the top. So the centimeters, how are we getting the distance? We're getting the distance on the center point. So you see we have 2 line crossing. That's the point where we get the distance for all the objects that we can detect. You might wonder, why is the distance moving so fast? Why is it not stable and not so precise? That's not problem of the distance, because I can guarantee that the Intel RealSense is really precise when getting the distance. It's mostly about now the accuracy of the detection. As you see, the center point is moving quite fast, and of course not every single position has the same distance from the camera. So if the center point is first like on the center of my chest, it has one distance. If it moves a little bit on one side, it has a different distance. And now I'm going to try also from a longer distance, and let's see how this works. So you see the object now is almost 2 meters, 185, 87 centimeters. When it gets closer, you see that also the distance is smaller, while I'm keeping the same distance from the camera. And this is all for this tutorial. Of course, many things that I've done, for example, to display this, I've done it before to simplify everything, otherwise it will take a really long time to explain everything. I hope that you got some value from today's tutorial. And of course, if you need to adapt this to your project, you need to make some tuning also to make the sender more precise, and probably some other things that you will need to set for a project, like for example, speeding this up by installing the NVIDIA graphic card. If you have a company or you are a professional and you need consulting services, you can contact me at pysource.com. This is all for today's tutorial. See you on the next one.